Good morning, everyone. Today we're looking at Unit 4, Lesson 7, Trig angles and the cast rule. So we're going to continue exploring those angles on the Cartesian plane from 0 to 360 degrees. But today we're going to look at how do we know when those trig ratios are positive or negative, and in which quadrant are they positive and negative. So recall that an angle on the unit circle can be represented using the primary trig ratios. So we talked about this yesterday, where the legs of our triangle are x and y, and then we could say that the sine of theta is our opposite side, which is y, over our hypotenuse r. Cosine of theta would be our adjacent side, which is x, over our hypotenuse r, and tangent of theta is our opposite side, which is y, over our adjacent side, which is x. So we're going to use our special triangles, and we're going to do a little bit of exploring about these different angles and determining when are they positive and when are they negative. So we're first going to do this just looking at our sine ratio. So let's use special triangles to find the exact value and sign of the sine ratio of the following angles. So I'm going to start by drawing these different principal angles. So if we were to draw 30 degrees, okay, well, a 30-degree angle is going to be in my first quadrant. I'm going to make that into my triangle, and you can see that we're going to create here a 30, 60, 90. So I know the legs because that's one of my special triangles. 1, radical 3, and 2 for my hypotenuse. So if I wanted to identify my related acute angle, it's in my first quadrant, so my principal angle is also my related acute angle. So it would be 30 degrees as well. The sine ratio of 30 would be my opposite. Remember, sine is opposite over hypotenuse. So my opposite side is 1. My hypotenuse is 2. Is it positive or negative in this quadrant? Well, it's a positive 1/2, so it's positive. And which quadrant are we in? We are in quadrant 1. And then let's just label our quadrants again so we all remember. Quadrant 1 starts there with our positive x, positive y, and then we move in a counterclockwise rotation. So there's our 4 quadrants. Okay, if we had 150 degrees, so 150 degrees would be somewhere in quadrant 2, right? We'd say this is 150 degrees. Okay, and then we could say that this related acute angle would again be 30 degrees, right? Because 150 plus 30 is 180. So again, we've created this 30, 60, 90 triangle. We're going to again label those side lengths. But we have to think about, are these negative or are they positive? Well, my x is going to be negative because I'm on the negative part of my x-axis, but my y value is still positive, and so is my hypotenuse. So in this case, if we were to identify our related acute angle, we can see that it's 30 degrees, right? It's that angle between the terminal arm and the x-axis. Our sine ratio, so our opposite side over our hypotenuse, so still a positive 1/2. So we'd say the sine is positive, and this is in quadrant 2. So we're going to continue on with this. If we were to do 210 degrees, that would fall somewhere in the 3rd quadrant. And again, we'd have a related acute angle here of 30 degrees. So hopefully we can see where this is going, right? We make our triangle. We have a 30, 60, 90 degree triangle, and we can label our side lengths again. So now again, we have to evaluate, well, what's negative and what's positive? I know my x is negative, but now my y is also negative. So my related acute angle again is 30 degrees. My opposite side is negative 1, and my hypotenuse is 2. So this time, our sine ratio is negative, and we are in quadrant 3. Okay, let's do that last one. As you can imagine, see if I'll go all the way around. If I wanted to do 330, we'd be over here in our 4th quadrant. Oops, let's try that again. Okay, and we'd have a related acute angle again of 30 degrees, because 30 plus 330 would make that full 360. I'm going to connect my triangle, label all my angles. So we have to recognize again what's negative and what's positive. This time, our y this is a negative 1 here. So if I assess my related acute angle again is 30 degrees, my sine ratio is going to be my opposite, which is a negative 1 over my hypotenuse 2. So again, my sine ratio ends up being negative, and this is in quadrant 4. So if we were to answer how many times in 360 degrees is the sine ratio positive, well, we can see here that we went all the way through these related acute angles with a 30-degree related acute angle in each quadrant, and 2 times they were positive, right? And that occurred in quadrant 1 and in quadrant 2. So how many times in 360 is the sine ratio positive? 2 times in quadrant 1 and 2. Okay, so we're going to do the same thing with our cosine ratio. I'm just going to use the angles I already have drawn up here in my triangles. So our related acute angle for a principal angle of 30 is still 30 degrees. As you can see, all of our related acute angles, we already saw this in the first table, are going to be 30 degrees. That doesn't change. That's that angle between our terminal arm and our x-axis. So if we evaluate our cosine ratio, well, if I look at my blue triangle here for a 30-degree principal angle, my cosine ratio is going to be my adjacent side over my hypotenuse, which is a radical 3 over 2. Now if I follow that 150, so that's my red triangle here in quadrant 2. Oh, actually, before we do that, let's assess positive or negative. So 30 degrees, my cosine ratio is positive, and that is in quadrant 1. I'm going to pause the video. You guys go ahead and do this for the next 3 angles and fill out the table of values. And if you can, go ahead and answer that question, how many times in 360 degrees is the cosine ratio positive and in which quadrants? So if we finish filling in our table of values here, we can see that the cosine ratio ends up being positive in our first quadrant and in our second quadrant. So again, 2 times in a 360-degree period, we have a positive cosine ratio, and that's in quadrant 1 and in quadrant 4. All right, so let's now look at our tangent ratio. So again, we're going to use those special triangles to find exact values and signs of those tangent ratios of the following angles. So we know our related acute angles were 30, 30 for all of those, right? They were just in different quadrants. Now, if we're going to identify our tangent ratio, I'm going to pause this and draw those special triangles on the Cartesian plane again. So then we'll have them there to look at while we fill in this table of values. Okay, so here we have our special triangles again, exactly as they were on the first page. So if we were to look at our tangent ratio for our 30-degree principal angle, that's my blue triangle here. Tangent, remember, is opposite over adjacent. My opposite side is 1, and my adjacent side is radical 3. And that is positive, and we are in quadrant 1. So I'm going to pause the video. You guys go ahead and finish those tangent ratios for the rest of the table of values. Okay, so here's what you should get when you fill in that table of values. We end up having positive tangent ratios in quadrant 1 and in quadrant 3. So something I want to point out about quadrant 3 is you can see that our tangent ratio ended up being a negative 1 over a negative radical 3. And we know that a negative over a negative makes a positive. Right? So we've looked at where these trig ratios are positive in which quadrants for all of them, for sine, cosine, and tangent. And we actually have a rule in mathematics we use called the CAST rule to help us remember where they're positive. So the CAST rule goes something like this. Our sine ratio repeats in the first and second quadrant, meaning it's positive in the first and second quadrant. And we identify this with this little formula. So our sine of theta would be our sine in quadrant 1. And that sine of 180 minus theta, well, if we look at this little graphic below here, 180 minus theta is my sine ratio in quadrant 2. So they're representing, saying that the sine ratio is the same in quadrant 1 as it is in quadrant 2. Okay? And then we can look at this the same way with our cosine. So our cosine ratio repeats So our cosine repeats in quadrants 1 and 4, meaning it's positive in those quadrants. And we can see that the cosine ratio, so cosine of theta, that's cosine in quadrant 1, is equal to our cosine in quadrant 4, that related acute angle we represent with that 360 minus theta. All right, and then finally our tangent ratio repeats in quadrants 1 and 3, and that can be represented by saying that the tangent of theta, which is our quadrant 1, is equal to our tangent of 180 plus theta, which we can see right there in quadrant 3. So we use the letters of the word cast to remember this word, or this rule. So let's first, again, identify where our quadrants are. We have quadrant 1, and then we move in a counterclockwise rotation. Well, the letters of cast actually start in our 4th quadrant, and they move in a counterclockwise rotation. We're going to talk about what does that really mean. So we'll put C in quadrant 4, A in quadrant 1, S in quadrant 3, and T in quadrant, S in quadrant 2 and T in quadrant 3. So this cast rule lets us know which primary trig ratios are positive in each of the quadrants. The letters of cast start in the 4th quadrant and go counterclockwise. So what this is really saying is if I have this C down here in my 4th quadrant, that's telling me that only cosine is positive here. So it's positive in 4. The A up here in quadrant 1 tells me that all ratios are positive in quadrant 1. Okay, and yeah, I guess you guys can assume where we're going with this. So the S says that sine is positive in quadrant 2. And finally in quadrant 3, tangent is positive in quadrant 3. So that's the idea behind the cosine rule. You can see that in quadrants 2, 3, and 4, only one of the trig ratios is positive, but all of them are positive in quadrant 1. So we're going to look at some examples of how we can apply this cast rule to some trig problems. So if we're given that cosine of theta equals 4 over 5, we need to determine the possible values. So the key word there is possible, which means may be more than one solution, right? There might be more than one solution to this problem. So determine the possible values for theta, where theta is between 0 and 360 degrees. Then determine sine theta and tangent theta. So let's take a look at this. We're going to draw this on a Cartesian plane. Let's first use our cast rule to see where is this going to go. So remember, our cast rule starts in that 4th quadrant and then moves in a counterclockwise rotation. So it says, given that theta equals 4/5, well, this is a positive 4/5. So we know cosine is positive in quadrants. Based on my cast rule, we're positive in quadrant 1, because they all are, and also in quadrant 4, because that's where the letter C is. So that means I have to draw this angle of theta in both of those quadrants. So I'm going to draw in quadrant 1, this can be my theta, and I'm going to draw it in quadrant 4. That's going to be my theta. Okay, and then again, I'm going to make those triangles from those terminal arms. So we know cosine is positive in 1 and 4. We also know the cos of theta is equal to adjacent over hypotenuse. So that's where we're going to plug in this fraction of 4 and 5. So if theta is here in quadrant 1, my adjacent side would be that side touching theta, and my hypotenuse is there. Same for this other one in quadrant 4. We have an adjacent side of 4 and a hypotenuse of 5. So let's determine what theta is in each of those quadrants. So let's start with in quadrant 1. So in quadrant 1, cosine of theta equals 4/5. Well, we need to isolate, and we're going to call that theta 1 actually, because we're going to have more than one, because we have a theta in quadrant 1, and we have one in quadrant 4. So we'll call those theta 1s and theta 2s. So to solve for theta 1, we need to take the cos inverse of 4/5. And when you take the cos inverse, you should get 36.9 degrees. All right, and then if we want to determine what theta is going to be in quadrant 2, or sorry, in quadrant 4 rather, we can simply take that 36.9 and subtract it from 360. Because we can see here that 36.9 is just going to be our related acute angle. So theta 2 is going to equal 323.1. So just want to explain that again. So if this is 36.9, this is 36.9, right? So if we wanted to measure the principal angle of this, we'd go around counterclockwise to there, and we would find that that is the 323.1. So we want those principal angles. All right, the next step of this is to find our sine and tangent ratios. So we need to find, well, what is this third side of my triangle? Once we know for one of them, we'll know for both of them. So let's do our Pythagorean theorem to find that. So we know that x squared, which is 4, plus y squared equals 5 squared. So we have 16 plus y squared equals 25. And then we'll move that 16 over by subtracting it. And then finally take the square root. So we know y is 3 in quadrant 1. In quadrant 4, though, that's going to be a -3. Okay, so we need to identify those ratios. So in quad 1, the sine of theta is going to equal my opposite side over my hypotenuse, so 3/5. And the tangent of theta is going to equal my opposite side over my adjacent side. And then if we want to do this in quad 4, the process is the same. So the sine of theta, in quad 4, my opposite side is a -3. And my hypotenuse is still 5. And my tangent, again, is a -3/4. All right. Let's set up the next one together, and then we'll pause the video and have you work through the problem on your own. So it says, given that tangent is equal to a -1/3, determine the exact value for theta, where theta is between 0 and 360 degrees. So remember, tangent is O/A. But now we have to look at, where is it negative? So if we were to draw our Cartesian plane and we wrote the letters for cast, we can see that tangent is going to be negative for S and for T. So that's in quadrants 2 and in quadrants 4. So we would say, we know tangent is negative in 2 and 4. So that's where we're going to draw our terminal arms from. So go ahead and see if you can work your way through this problem. Keep in mind that tangent ratio to me looks like one of our special triangles. So you might create a special triangle, but see if you can work through finding the values of theta for this question. So there's the solution for this problem. If we were to continue filling out the triangle, you would hopefully recognize that when we label our sides, our opposite and our adjacent sides, we have the side lengths of a special triangle, that 30, 60, 90 special triangle. So that would tell us that our theta in this case is 30 degrees. And then once we have the 30 degrees, we can work with that 30 degrees to figure out our angles in those quadrants. So if we're in quadrant 2, then to get to that related acute angle of 30, we'd have to first go 150 degrees. So that would represent my theta 1, which we could have found by subtracting that 30 from 180. All right, in quadrant 4, again, our related acute angle is still 30 degrees. So our angle there is 330. We have to go all the way around to quadrant 4, 330 degrees. So we would do 360 minus 30 to get that 330 degrees. So you could just wrap that up with a therefore statement and say, therefore the two angles are 150 degrees and 330 degrees. That's it for your notes for today.